So we'll be talking about properties of exponents. You should be putting this into your study journal. And this is a review from things that you've already learned either your freshman year or in 8th grade. If this does not seem like a review, that makes the notes even more important. So again, we will do the name of the property, then in the next column in your study journal, we will do the definition of that property, and then in the final column, we will do an example. So the first couple you'll see as a part of other examples, and that is the zero exponent property. Zero exponent. And essentially the definition for that is any number raised to 0 is equal to 1, as long as a is not 0. 0 to 0 doesn't make sense. So any number to 0 is 1. So let's do some examples. Negative 83 raised to the 0 power is 1. 27 to the 0 power is 1. Anything that I put here becomes 1. One common error, and I'm going to do this in red because it's a common error. If I have negative 83 not in parentheses raised to the 0, then this first section, the 83, this area here, this becomes 1, and the negative still hangs around because the negative was not in parentheses, as you can see over here. So that's the only common error you need to be aware of. Otherwise, anything raised to the 0 power is going to be 1. Okay, let's go to our next property. Again, you'll see this in the context of other problems. We call this the negative exponent property. So I'll just kind of draw a line through here, meaning that we're kind of done with this property. Property definition and example. And now we're on to the negative exponent property. So any number raised to a negative exponent is really the same thing as 1 over that same number raised to the same exponent without it being negative. And again, a cannot be 0, that's not going to work in these, but any other number that you put to a negative exponent, it just turns it into a fraction where the numerator is 1 and the denominator is the same base and exponent forming that power. So let's look at some examples. An example would be 6 to the negative 2 is really the same thing as 1 over 6 squared. A second example might be 54 to the negative 3, and that's going to be 1 over 54 cubed. So first couple of rules you're going to see in the context of other information. These next rules you'll see as actual simplification that you're doing. Okay, so the first one that we want to talk about is the product of powers. Product. What's product mean? It means to multiply. So product of powers. What are powers? Powers are a base and an exponent together. So product of powers. So any base to some power times, that's the product, of the same base to a different power is the same thing as that base with the exponents being added. So I've got the power am times the power an, and I end up with a to the m plus n. And if you looked at that in an example, I mean, that could be something as simple as 5 cubed times 5 squared is 5 to the 5th. How did I get this 5? It's 3 plus 2. It could also be the same thing as 5 to the 4th power times 5 to the negative 1 power, which is 5 cubed. 4 plus negative 1 is 3. So again, 4 plus negative 1 is 3. I'm still adding them. I end up getting 3. That's our product of a power. Okay, our next rule, we'll scroll down to get some more space, is going to be a power of a power. So power of a power. Remember, power means that you have a base and an exponent. So we're taking a base and an exponent and giving it another exponent. So any base to an exponent raised to a second exponent is power of a power. We have a power of a power. Two exponents happening on top of each other. So that ends up being the same thing as the base times the two exponents multiplied by each other. So if I use a similar example as before in the product of a power, and I have 5 cubed times 5 squared, we knew that was 5 to the 5th. But if I rewrite it as 5 cubed squared, this is now 5 to the 6th power. Same thing is true if I have 5 to the 4th to the negative 1. That's actually 5 to the negative 4, which we know is 1 over 5 to the 4th. See how I combine those a little bit? And I want to write my 4 a little smaller, just so you know it's an exponent. Okay? I combined the negative exponent property with the power of a power property. We're going to jump into the last one that we're doing today. This is quotient of powers. And as you can see here, we will use this as division. That's what quotient means, is division. So I have any base to an exponent divided by the same base to a different exponent is the same thing as subtracting the exponents. So if my example is 6 cubed over 6 squared, then this becomes 6 to the 1 power. 3 minus 2 is 1, or in other words, it's just 6. Likewise, if I have 6 to the 4th power over 6 to the 7th power, that becomes 6 to the negative 3, which is the same thing as 1 over 6 cubed. So those are our basic properties. You'll see that sometimes you have combinations, and if they're combinations where the base is not the same, then you're not going to combine them. So here's a common error. If I have 3 squared times 4 cubed, that is not 12 to the 5th power. That is absolutely wrong. I've done it in red because that is absolutely incorrect. The correct way to represent this, which I'll do in green, 3 squared times 4 cubed cannot be simplified, so I'm just going to leave that alone. You'll also see that in variables. X squared times y cubed cannot simplify, you leave it alone. Okay, same thing is true if you have x cubed times x squared, same base, this becomes x to the 5th. You can simplify it because x matches x. Here, in this other example, x and y do not match. Those are the common errors to be aware of. Good luck on the problem set. If you have questions, go ahead and post your questions, and we'll get those answered.